All right, ladies and gentlemen, in this video, we are going to set a goal. Now listen on up, all right? We are going to be utilizing what we know about the distance from a point to a line to find the distance from a point to a line if we are not given the perpendicular segment. Let's think here first and foremost. What is the distance from a point to a line? Remember, some people say it's just a straight line. No, the distance from a point to a line is the perpendicular segment that connects a point to the line. So we have to find, in this case, what the perpendicular equation is going to be. Sometimes when they give it to us, they'll see, hey, point 1 comma 0, and then they'll give us what the other point is. Without 100% knowing what the other point is, we have to draw some conclusions by creating the intersection of two different lines. Hang with me. I put some step-by-steps together to help us kind of guide through the process. All right, so we know that we want to find a perpendicular equation. All right, we know that because the distance from a point to a line is a perpendicular segment. So let's first and foremost identify what that perpendicular line slope is going to be. Well, if we kind of use this just as step one, kind of identify what step one is. All right, so if we think about step one says that, hey, the original slope of y equals negative x plus 3 is a negative 1. So that means that my perpendicular slope is going to end up being a positive 1. Off to a good start. Okay. Now, for 2, we want to identify what that y-intercept is of the line. Okay? And we got to think here for a sec. We know that it goes through the point 1 comma 0, right? So that is going to end up being that one extra little point. Now you can utilize slope-intercept form, you can utilize point-slope form. It's completely up to you of how you want to utilize it. Let's go ahead and think about what we know. We know that the point 1 comma 0 lies on this line, and it also has the slope of positive 1. So if I use my point-slope form, I have y minus 0 equals 1 times x minus 1. This comes out to be y equals 1 times x is x, and 1 times negative 1 is, of course, a negative 1. So now we have actually found the new equation for the point of intersection. So if you kind of see here, y equals x minus 1, we will now be taking our new equation of y equals x minus 1, our old equation of y equals negative x plus 3, and set up what we call a system of equations, to actually identify where that point of intersection is going to be. All right, well, what does the system of equations look like? And I'm going to erase our screen just for right now. So what is our point of system of equation? So we've got the line y equals negative x plus 3, and we have the line y equals x minus 1. Well, I like substitution in this particular case because it's basically already separated out for me. I can take one of the y equals and substitute it into our other one. So let's go ahead and do just that. So if we have substituting x minus 1 into our 1y, we get x minus 1 equals negative x plus 3. Combining like terms, I get 2x, and I add the 1 on over, I get 4, divide through, and I get x equals 2. So this identifies the x coordinate of the point in which the two lines will intersect. So now let's go ahead and take my x equaling 2 and substitute it back into the other equation. So I will take x equals 2 and substitute it back into y equals negative x plus 3. to find out where the point of intersection is between these two equations. All right, so if that's the case, y equals -2 plus 3 leaves me at y equals a +1. So let's kind of just recap for a sec. We have the line y equals -x plus 3. We found that the line y equals -x plus 1 was, -x minus 1 was perpendicular to it. The point in which those two lines intersect is at point 2, 1. So where do we go from here? Well, if we know that 2, 1 is on the line, and we know that 1, 0 is on the line, it's our job to find the distance between those 2 points. So our distance formula says that y2 minus y1, so we get y1 minus a 0 plus 2 minus 1, all quantity squared, square root. 1 squared is 1, 2 minus 1, and when it's all said and done, the distance between those 2 points is square root of 2.